So today we're going to be talking about London dispersion forces. And we know that London dispersion forces are the weakest in terms of intermolecular forces. These are the forces that occur because of random motion of electrons on atoms within molecules. At any moment, a nonpolar molecule could have more electrons on one side than the other. So for example, if we draw an atom with its electrons symmetrical from each other, this will create a no temporary dipole, where if we have an atom with its molecules and electrons on one side, we know that since they're all shifted to the negative side, it'll create a temporary dipole that is negative and make this molecule nonpolar. Okay, so we know that all molecules contain London dispersion forces. But a London dispersion intermolecular force only exists between noble gases and nonpolar. So if we draw out, say, CO2, we know that C is in the middle with 2 oxygens. So we know we have to create 8 in the middle for carbon, and then since we already have 2, we would give oxygen 4 electrons around it, and this would have no lone pairs around carbon, which means that all electrons are going to pull equal from each other. Another example we could draw is C2H6, and we know that we have 2 C's in the middle 6 H's around it. And we know that the C's are filled with 8 valence electrons, and we know that hydrogen only needs 2. So this would also have no lone pairs, which means that all the electrons are going to pull equally from each other. So a little way to remember this would be with the molar masses. So molecular size is the polarizability, and the polarizability is the ability to make a temporary dipole. So if we take helium, neon, argon, krypton, and xenon, we know that the molar masses increase. So as you move down this column on the periodic table, the atoms become bigger as we see the molecular size increases. Xenon has more electrons than helium, and this makes it polarizable because there are more electrons to move around the atom. So this would mean that the larger London dispersion forces between the molecules, they're easily polarized, and the weaker between molecules are not easily polarized. So as you move down the table, these are easily polarized. So now, if we want to just try out some questions here, let's go here. So I'll answer the question with, which molecule has London dispersion forces? So you can take the time to pause the video now and draw out your molecules to answer this multiple choice question. Okay, so hopefully you've drawn out each molecule, because that's the easiest way to try to figure these out. So we know H2O has 2 H's, an O in the middle, and another H. Okay, so we know that O will have lone pairs up on the two sides to fill it with 8 valence electrons. So this could be a possibility. Then if we have CH4, we know that this won't have any lone pairs because carbon is already filled. If we draw HF, we see that there are no lone pairs, which means that C could also be an answer. And then if we draw BF3, we have B in the middle with F, F. And we know that we have to fill the F's with 6 electrons around it to fill them. And we said this will be no lone pairs as well, so we know that BF3 won't be a correct answer. So if we know that CH4 and BF3 aren't right, that leaves us with H2O and HF. Now both don't have, we know that this isn't right because F is more electronegative and it pulls. So we know that HF won't be correct, which will leave us with H2O. So now if we come down here, we'll try out another problem. So you're going to draw out CCl4 and SCl2, and then we will decide which is polar and nonpolar. So you can take this time to pause the video and try this out. Okay, so if we draw out CCl4, we know that C has 4 valence electrons and Cl has 7 valence electrons. This would give us, well, since we have 4, this would give us a total of 28 plus the 4, which equals 32 valence electrons total in this molecule. So then that means we would have to add electrons to each one to equal 32, which it does. This has no lone pairs, which means that we would have a non-polar molecule. Where if we draw CCl2, this would be a polar molecule, because it has no lone pairs. Or if we draw CCl2, we know that Cl has 7 valence electrons and S has 6 valence electrons, which would give us a total of 20 valence electrons. And if we draw around and we fill them up, we see that S is not filled with 8 valence electrons. We still need 4 more to equal 20. So that means we have to add on lone pairs, which these lone pairs would create the temporary dipole, which would mean that it was non-polar. So after learning today, I hope you understand London dispersion forces a little better.